Hello. Hi. Wicket got a haircut, and he's going to sit on my lap while I teach you about human genetics. So, when we study human genetics, some problems can actually arise. We can't usually get true breeding or pure breeding just because we've seen lots of generations that have, come to pass, and so it's really hard just to get all dominant alleles that are homozygous. Obviously, using a test cross in a lab is very unethical because a scientist would actually have to choose who humans mate with, and most humans aren't going to go for that. Plus, that's a lot of stress on the body, and the turnaround time to see the offspring is very long. We can't produce enough offspring, it takes too much time, but we can use some methods. So we can look at population sampling, where we can just look at the population to count the traits within a given area. That's one way. We can look at twins. Twins is a great way to study the genetics of a human because you're able to compare the differences and similarities, if any, exist. Karyotyping is one that's used where we can actually look at the chromosomes themselves and study if there's an abnormal chromosome, a missing chromosome, or extra chromosomes, and we can learn a lot from that. And then pedigrees, and I'm going to teach you about pedigrees. Pedigrees are a diagram that show family relationships. They'll take a look at the generation and what is transmitted through the generation as far as their traits go. And we can determine if a trait is autosomal or if it's sex-linked. So are we looking at all of our cells, or is it only linked to the X and the Y chromosomes? And we can see if there's dominance or recessive in the traits. So a little bit about how we annotate pedigrees, how you make them and how you read them. We have boxes that are males, so this right here is the male, and the circle is the female. So that's how we can identify our pedigrees. And so you need to make sure that you understand how to read and how to make a pedigree, because you won't be given a key or the information in a pedigree. If it's shaded, the trait is going to be, that's the trait that's expressed. That's a trait that we're talking about that you will see. If it's half shaded, you may see a pedigree that has half shading, or you may want to make your pedigrees with half shading. But that would signify that the trait is heterozygous and that person is a carrier of the recessive allele. And a horizontal line, we could see right here, between the male and the female represents marriage or the fact that they've had a baby. And then a vertical line, which we see right here, represents the offspring. So this right here is going to be the offspring. There's offspring right there, and then the last one. So this person right here is not offspring, but this person rather is the male that married the offspring of the parents from the first generation. If there's a Roman numeral seen out to the side, that may represent the generation. So you might have Roman numeral 1, 2, and 3. Okay. And an Arabic number, or just a simple number underneath the people. So we can say 1, 2, 3, 4. So you might have Roman numeral 3, person 4, and that may be annotated like this. Or the other way. Put the parentheses here. 4. Okay? And so if there is a trait that is dominant and autosomal, so looking at all the other chromosomes except the sex chromosomes, you will see a good amount within male and female, because they're definitely not going to be linked to the X or the Y, that will be affected by the trait. And when we do problems like this, we can go through and test it. So this person may be that, this person would therefore have to be this. So that is how these two people may get, here, our dominant person, this person is going to be recessive, and so on and so forth. And then you can determine what the offspring of the third generation would be by whoever that they marry. And the trait for a dominant autosomal will usually be present in every generation, which is due to the fact that the phenotype of the dominant autosomal alleles are always present if they are actually shown in the alleles. So you'll end up seeing this in every generation typically. Something that might be recessive autosomal that you can maybe recognize is that there's an equal amount of males and females, but the trait itself might skip generation, and this is because it's recessive. So the trait up here, the trait down here could be the little alleles. Therefore, this person, right, these people right here would have to be heterozygous in order for these two offspring to actually come out as recessive for their alleles. And if it's sex-linked that is present, more males will actually be affected than females because we typically study our sex-linked traits on the x-axis. And so over here, you will have an XY, actually let me write that a little bit bigger, X and the Y, and you may have the trait being represented like that. And so this mother would have to be recessive and not express the trait because the males don't have it either. But she could be heterozygous for it as well. We have to run more tests and look at the pedigree further in the generations or if they had more offspring. And when you do write the genotypes, you want to make sure that you write it as X and Y. Remember, X and Y will always tell us that we are talking about sex-linked genes.